So for naive Bayes, we're going to have to come up with for each possible value of the predictors. Okay, so we're not going to look at both at the same time. We look at individually L and then N. Okay, here there are only two, so it's actually you might find that the naive Bayes is even more computationally burdensome than the exact Bayes because there are only two of them. But when you have lots of predictors, this one is a lot easier, as we will see in another example. So we have the prior probability P of F. We already have that right at the top somewhere over there. Okay. Now you look at, instead of looking at L and N given F, we separate them out. Okay. So here in the case of L and N, we looked at P of L and N given F. Right. So now we're going to do P of L given F and P of N given F. So again, in a small data set like this, we can easily figure this out. So among the fraudulent, how many L's are there? Okay, so it will be like 3 over 4. But then if you have a large data set, then it is better to prepare pivot tables. So I'm going to do 2 pivot tables. Okay, I'll put it here and then move it where I want it. Okay, and status goes as columns, and we want the 2 that we want is prior legal trouble is 1. Then bring status in here, so that will give you one table that we want. And we want one more table. Then let's put it here first, and then we will move it. Status goes in the column, size, and status again for values. Then we'll move it right there. Okay. So now we want L given F. So now we don't have joint table, we have individual tables. L given F, so it will be C79 divided by C81. Okay, of course, in a small data set, we can really browse through the data, complete data, and figure that probability out. But when you have large data set, you should prepare a pivot table like this and then use the values from there. So now N given F will be from here, so that will be C73 divided by C75. Okay. So now you multiply these 3 values. Okay. Now if you have more predictors, so you will have 1 row for each of those predictors. So now we have only 2. So that's it. So now we use the function called product of those 3. Okay, so that is 1. So in our, okay, so here that will be like one of those. P of C sub 1 times P of X sub 1 given C sub 1, P of X sub 2 given C sub 1, and so on. So that is one piece. And then you have to repeat that for each of the possible values of the target. For our example, there are only two, truthful, fraudulent and truthful. So we repeat this computation for truthful. So that would be probability of t, which we already have, or we can compute it again. Now this time, using this column, we set up these two probabilities. Probability of L, so that will be D79 divided by D81. Okay. And then D, so now we want N, so D73 divided by D75. Okay. So now you must find a product of that. So now if you add these two, that's our denominator. This is our denominator. If you go back to the PowerPoint slide, you see that part. We had only two possible C values, that's C sub 1 and C sub 2. C sub 1 being fraudulent, C sub 2 being truthful. But if you have more than T and F, then you just keep doing that and add them all up. That's your denominator. And the numerator is whichever one that you want. If your event is fraudulent, then you use that. So you will have that divided by the sum. So this will give you the propensity for fraudulent for L and N, okay, and then for truthful. So this is like our posterior probabilities, and this is approximate because we did not use the exact naive method and we relaxed that. So this will be somewhat different from the exact. Here 0.33 and 1, so we have 0.31 and 0.68. It's a slightly different probability.